Hello, everybody. How are y'all doing today? Well, I see you. If you watching my videos, then that means that you need a little help, and that's okay. I'm going to help you out. Make sure that you understand what intermediate algebra is all about. We're going to cover the subjects sections that deals with the real number system, operations with real numbers, powers and square roots, and the order of operations. So in Florida, intermediate algebra will be up underneath the course number MAT 1033. That's MAT 1033. Okay, well, let's jump right into it. So, what is the real number system? Well, basically, it defines the type of numbers or problem that you're dealing with. So, we have natural numbers, whole numbers, integers, rational, irrational, and real numbers. So what are whole numbers? I'm sorry, what are natural numbers? Let's start at the top. What are natural numbers? Well, they're also called positive integers, right? Which means that you are not going to get any negative numbers. And they also start off at one. So we talk about natural numbers, you're going to be one, two, three, four. I mean, just infinity, all the way up to infinity. This is what we consider natural numbers. Whole numbers, on the other hand, will start off at zero. So you get it, and also natural numbers, they're also called the counting numbers. So we're gonna just put it right here, the counting numbers. Please excuse my handwriting. But the whole numbers will start off at zero. That'll be zero, one, two, three, dot dot dot. And let me tell you about these dot dot dots that you see right here. These are also called ellipses. So when you have math problems and you see these ellipses, they're basically telling you that this number or this problem or whatever will go all the way up until infinity. Infinity meaning that there is no stopping. Okay. Let's jump into integers. Integers are negative numbers are included. So you have negative two, negative one, zero, one, two, and etc. Okay. That's what integers that's that's what we call integers. Rational numbers, on the other hand, are integers, but they are the quotient. They can also be the quotient of integers. Okay, because what you already know what quotient is, means that you're dividing by something. So with that being said, that means you're going to get some decimal numbers. Now, what I will warn you though, when you're dealing with rational numbers or any type of division problem, just remember that you cannot divide by zero. No matter what that number is, you cannot divide by zero. Later on in your math journey, if you run into some numbers like this here, that means that you did something wrong, or that means that you're in calculus. But that's another story. We'll jump out, create a video for that. But right now, no, no. You cannot divide by zero. So let me write down some examples of some rational numbers. Let's see if I can find some, think of some that I can. Okay, well, we got negative six. Remember, they're integers, quotient of integers as well. So you got negative six, and these are just numbers that I'm throwing out there, nothing particular. Negative four, negative two, or you get over here, you go 15 divided by four, or 16. Let's see, divided by four. These here are not in order, but I'm just giving you the hint of what's going on. So irrational numbers are non-repeating decimals and non-terminating. decimals. So let me show you what I'm talking about. Let me erase this over here. Let me show you what a terminating decimal is. Okay, so just say for instance we have a problem as 1 divided by 8, which will equal 0.125. This here will be considered a terminating decimal. Okay, because that means it's not going anywhere. It's terminated. That's it. That's all you're going to get. Okay, so an irrational number would mean that this would be a non-terminating decimal. So that's going to that number is going to keep on going. Okay. Now, it also irrational numbers means that it's a non-repeating decimal. So let me show you what a repeating decimal is. So if I had this 2 divided by 3, which will equals 0.6666. You see how that repeats right there? So an irrational number would mean that it would be a non-repeating decimal. Also, by the way, when you have a problem like this, a repeating decimal, they have a sign, so you don't have to write all these repeating digits. They have a sign to where you can just do this. Let's say 0.6 to 6. You can put a bar over that. That lets you know that this is a repeating decimal, that it's going to keep on going, repeating the same numbers. Okay. As a matter of fact, let me go ahead and write down some irrational numbers for you. These are some real numbers: negative 2 pi. We'll get into all of that later. Negative pi, 1.5 pi. And again, these are not in order. So if you calculate these, I'm quite sure that this number here will be bigger than that number or smaller, whatever you have. But yeah, that's what that is. 1.5 pi, negative square root 15. These are all irrational numbers. Negative square root 16, and so on. Okay. So what are the real numbers? Real numbers are rational and irrational numbers, which basically describes the subject matter. Rational and irrational numbers. Okay. Now, real numbers also have properties. Now, there are some characteristics of real numbers that we have found to be true. Okay. So let's get into the properties. For example, well, let's go over the properties of real numbers. We have the commutative, associative, identity, and inverse. All of these are properties of real numbers. So what are the commutative? For example, we know that we can add any two real numbers, and the order in which we add the numbers does not affect the sum. So that's this is what mathematicians call the commutative property. So we had a number like this here. We had a 4 plus 3 on one side and a 3 plus 4 on the other. Since all the real numbers have this correct, we can we can also write this property using letters too. So we had a b plus a, and then an a plus b. So regardless, it will not affect the sum. It will not affect the sum. You're still going to get what you're going to get. Okay. Now, another property which you may be familiar with is the associative property. And that states that in which you group numbers that does not affect their sum. For instance, if we had something like this, if we had a 4 plus 3, we're grouping that together, plus 2, and if we have a 2 plus 4, plus 3. You see this here? This will not affect the sum because you get 9 over here and you also get a 9 over here. It does not affect the sum. So the identity property from an addition perspective state that we add a unique real number, which is also called identity element to any other real number, that number is not changed. Unique means one and only. One such number has this property. For addition, 0 is the identity element. For addition, 0 is the identity element. So if we had this problem right here, if we had 33 plus 0, and then we have a 33 on this side. Regardless, you're still going to get a 33 because it does not affect the sum. Okay. And the last property is the additive inverse property. And what that says that for any real number A, there is a unique real number, negative A, such that if we add them, we obtain the identity element. So for example, if I have a number like this here, 7 plus a negative 7, what you think I'm going to get with that? A 0. A 0. Same thing if I was to use some letters. So if I had a B plus, let's say, a negative B, this best describes the inverse property. This best describes the inverse property. So, well, and there you have it. I just went over the number system with you, and I went over the properties. So what we're going to talk about in the next video is the operations with real numbers. Okay. So I would like to tell you thank you for joining me, and I will talk to you soon.